Hello everyone, today we're going to look at how to calculate a one sample interval for the mean, and we will look at an example and two different ways of solving the example. So we want to find one sample intervals for the mean when, say, we want to estimate the mean height of Americans, or we want to estimate things like the mean salary of college graduates. A confidence interval for the mean would be the way for us to estimate these means. We start out, a lot of this is kind of similar to stuff we've done before, by stating the random variable and the parameter in words. So x is the random variable, and mu is the mean of the random variable. We want to state and check the assumptions for a hypothesis test. Then we want to find the sample statistic and confidence interval. So the confidence interval is the interval x bar minus e is less than mu is less than x bar plus e, where e is t sub c times s over the square root of n. This is a little bit different from the e that we calculated whenever we found a confidence interval for proportions. In this case, x bar is the point estimator for mu, so we're still looking at a point estimator. Now we're looking at t sub c. This is a t critical value from students' t tables. This is a critical value where c is the confidence level, it's 1 minus alpha, and df, which stands for degrees of freedom, is n minus 1. The idea of a degree of freedom is basically the number of things that are allowed to vary. For example, if you have 5 chairs and 5 people, there are 4 degrees of freedom because only 4 people get to choose a chair, and the last person has to sit in whatever chair is left. And this is kind of the idea of why our degrees of freedom are the sample size minus 1. S is the sample standard deviation, N is the sample size, and E is the margin of error. Again, we have this statistical interpretation, which in general looks like there's a C% chance that the statement contains the true mean. And there's this real-world interpretation, which is almost the same thing, but this is just where you state what interval contains the true mean. Again, our critical value is a value from students' t distribution. This is a distribution created by a man named W.S. Gossett, who is the head brewmaster at Guinness. Interestingly enough. Let's look at an example of how to put all this together. Here we have a random sample of 20 IQ scores of famous people was taken from the website of IQ of Famous People, and then a random number generator was used to pick 20 of these IQs. Find a 98% confidence interval for the IQ of a famous person. The first thing that we want to do is type all of our data into our calculator. So we're going to do this the quote-unquote hard way. I don't think it's actually going to end up being that difficult. I've already typed all of my data into my calculator. In order to type the data into the calculator, you just go stat, edit, and I just typed everything into L1, all 20 values. And now that we have everything typed into our calculator, we can state our random variable and our parameter in words. Our random variable X is the IQ score of a famous person. Mu is the mean IQ score of a famous person. Again, we have typed all of the data into our calculator. So now what we're going to do is we're going to go to stat. Then we're going to go write once to calc. And then we're going to choose one var stats and hit enter. There are similar functions in calculators online where you'll be able to type in the data and it'll be able to spit out the mean and standard deviation of the data for you. Because this is what we're looking for. We're looking for X bar, which we see as 145.4. And we're looking at SX. This is going to be our sample standard deviation. So this is about 29.27. Using one var stats is, of course, much easier than calculating the standard deviation by hand. Our degrees of freedom here, since our degrees of freedom are n minus 1, our sample size is 20, so 20 minus 1 is 19. And typically we find these t values from a table. Nowadays it's actually possible to use technology to find these as well. But here is an example. This is in Appendix A2 at the end of the textbook. Since we wanted to find a 98% confidence interval, we look in the 98% column, and we look in the 19 row because we're looking at 19 degrees of freedom. And we get that T sub C here should be 2.539. Then we need to calculate our margin of error. This is this T critical value times S over the square root of N. This is 2.539 times 29.27 divided by the square root of 20. We should get about 16.6 here. Our confidence interval is in the form X bar minus E is less than mu is less than X bar plus E. And this is 145.4 minus 16.6 is less than mu, which is less than 145.4 plus 16.6. So we end up getting 128.8 is less than mu, which is less than 162 as our confidence interval. Here, our statistical interpretation is that there is a 98% chance that this interval contains the true mean IQ score of a famous person. And the real-world interpretation is that the mean IQ score of a famous person is between 128.8 and 162. Once we look at stuff from Chapter 7, because in this case we're doing Chapter 8 before Chapter 7, we're going to be looking at questions like, is the mean IQ score of a famous person different from the mean IQ score of a non-famous person? As in, like, is the mean IQ score of a famous person higher than the mean IQ score of a non-famous person, for instance? We'll be looking at those kinds of questions. Now, as far as finding these t sub c values. Again, these critical t values are often retrieved from a table, as it was only recently that it became easy to do these inverse t calculations. There is an INVT function in TI-84 calculators. It's not present in TI-83 calculators. There is an even easier way. One sample t int. This is called t interval in a TI-83. It's called t interval. And this makes finding these confidence intervals incredibly easy. All you have to do is go to stat, edit, type in all of your data. Then what we do here is we go to stat, over to tests, and we scroll down all the way until we get to t interval. We want our input to be data. The list is whatever list we have our data typed in. Mine was typed in L1. We don't need to change the frequency thing at all. And our confidence level should be whatever confidence level we're looking at. Since we were looking at a 98% confidence level, we're going to type in 0.98. If we wanted a 99% confidence interval, we type in 0.99, etc. Then we hit calculate. And this outputs the confidence interval for us. The data that you see here is for a different problem. In case you wanted to check this one. It's for this problem, in particular. If we type all of this data into our calculator and we use the t-interval function, we should get this confidence interval.